Hey everybody, my name is Kelvin, and welcome back to episode 2 of my Learn Python series. Today, we're going to be introducing variables and data types. If you haven't watched episode 1, the episode is linked in the top right. Before continuing on this video, variables are how your program stores information. If you want your code to remember something, reuse it later, or update it over time, we can put that value in a variable. A variable is simply a name that points to a value. To set a variable in Python, we use assignment. You write a name, then an equal sign, then a value. For example, we can assign a variable called age equal to 21, just like so. The equal sign basically means store this value under this name. It's not an equation, but it's an instruction to Python. Moving on to data types. A data type is the category of a value. Python needs to know the type because different kinds of values are stored differently in the backend and behave differently. Even if you don't think about types yet, Python always does. The most important beginner data types are these. An integer, or shortened to int, is a whole number with no decimal point. Integers are used for storing things you count: number of messages, number of students, a person's age, quantity of items, a score, a year. If it makes sense to count it in whole numbers, we usually want an int. So our age variable that we just set is an integer. A float, just called a float, is a number with a decimal point. Floats are used for things like prices, measurements, averages, and anything that needs fractional values. Temperatures, distances, and money amounts often show up as floats. You'll see floats a lot whenever division is involved. Say, for example, we want to set age to a float. We can simply do that by creating into a fraction. This is a float data type. Our next data type is called a string, or shortened to str. This is text. Strings are used for names, sentences, labels, anything you will type as words, and also things like phone numbers or zip codes, because even though those look like numbers, you don't do math on them. If it's meant to be read or displayed as text, it should be a string. So for example, if we wanted to set age to a string data type, all we need to do is simply wrap it in double quotes. And this is a string data type of 21. The next data type that you must know is called a boolean, or just shortened to bool. It's a true or false value. Booleans are used for yes, no, or on/off states. Examples are variables called is logged in, has permission, is valid, or is student. Booleans become extremely important when we start writing conditional logic, because conditions are based on true or false values. So for example, say we have a variable called is old. We can set that to true, which is the true Boolean value, or we can set it to false. Now, our final data type is kind of a special case. None is a special value, which is just simply written as none. It represents basically no value or not set yet. You can use none when a variable exists, but you don't have a real value for it yet. For example, a user might not have provided a middle name, so you can store none. Or if you haven't calculated a result yet, so you start with none. For this example, we could interpret this as someone who hasn't been born yet. Someone who hasn't been born yet doesn't have an age. Python is a dynamically typed language. That means you do not declare the type ahead of time, like you would in C or something like that. You don't write, this variable is an int. Rather, you assign a value and Python automatically infers the type from the value. If you write age equals to 21, Python knows 21 is an int. If you write price is equal to $19.99, Python knows it's a float. If you write name is equal to a string value of Kelvin, Python knows it's a string. The type is attached to the value, and the variable name points to that value. Let's jump into some more concepts. Let's create a folder for this lesson, call it lesson 2, and open up a new file where we will store our first exercise. In this file, I want to touch a bit more on assignment. I'm going to type a few variables, print them, and then reassign one to show that variables can change. The key idea here is that the variable name isn't the value itself. Rather, it's a label, and you can point that label at a new value at any time. Say we had our age is equal to 21. Print statement right here. Age is equal to 22. Print age. Notice how we are using the same variable. I'll set this to my own name. And student is equal to true. And then we can, oops. And we can run this, and we'll see what happens. Get 21, 22, Kelvin, and true. We have to first understand what happened with age right here. We didn't edit the number 21. We reassigned the name age to point to 22 instead. The reassignment idea is going to show up constantly later when we do counters, totals, and anything that changes as the program runs. Say if we got rid of this print statement right here, we set age to 21 right here, and then we repoint it to age 22. This would only print 22, since we got rid of this value right here. Save that file and move into a different file for our next concept. Let's touch some more on data types. In this file, I'm going to create one variable for each core type and then print the value and the type. The reason we're doing this is so you can recognize these types early, because a lot of beginner confusion comes from accidentally treating text like a number or treating a missing value like it's already set. Let's create a couple of variables. Count variable, price, message, is open, equal to false. And we can create a couple print statements. So in this print statement right here, we're just going to print out count along with its data type. So you can see that count is 10 with the data type of integer. We can do the same thing for each one of these right here. We should expect to see 1999 with a float data type, hello with a string data type, is open with a Boolean data type, and value with a none type. If we run this, and we can see that that's exactly what we get. When we run this, we connect each type to the real use case. Count is an int because it's a whole number. Price is a float because it has decimals. Message is a string because it's text. Is open is a Boolean value because it's always going to be true or false. It's either open or it's not. Value is none because it represents no value yet. None is going to be useful later when we start writing programs where not everything has a value immediately. Moving on to our next concept. As I touched on before, Python is dynamically typed. Dynamic typing means Python decides the type based on what you assign. To show that clearly, I'm going to reuse the same variable name and assign different kinds of values to it. Again, the goal here isn't to encourage constantly changing types in real programs, as that's bad practice. It's to prove that Python doesn't require you to declare types up front, and that the type follows the value. So let's set a variable called x is equal to an integer 10. We'll print this with its type. Reassign it to 10 as a string. When you run this, the key takeaway is that Python is looking at the value on the right side of the equal sign and then deciding the type from that. The name x is just a variable name. It doesn't really have a fixed type built into it. So we can see that we can change x into multiple variable types. Our first 10 will print an integer, string, true, and none, corresponding with each of these print statements. Moving on to the next concept, variables make calculations readable. Here, I'm going to do a calculation with raw numbers first, then rewrite it with variables. Variables help with readability. Even if both versions work, the version with variables is easier to understand, easier to change, and easier to debug. Say we had a print value. Say we had a print statement of 8 times 60. Sure, we can print this and we would get 480, but in the context of the program, what would an 8 and a 60 mean here? We have no idea. We can do something else instead. We can do something better instead. We can set a variable hours to 8, minutes per hour, set it to 60, and then total minutes is equal to hours times the minutes per hour. And we can print total minutes. We can print this, and now this should make more sense. Both of these will give us 480, but this one makes more sense because it's human readable. We know that obviously hours, we have 8 hours, and we have 60 minutes per hour. And so total minutes here, so total minutes should be 480. And that makes more sense if someone else were to read our program. If we need to change hours, it's also pretty easy. We can do the same thing. Set hours equal to 10 instead. Reset minutes. Redo our equation right here. Reset minutes. And then we can see minutes right here. And now this should give us 10 times 60, which gives us 600 minutes. The next lesson I'd like to cover is that naming matters. The file is here because naming is not a style thing. It directly affects how easy it is to understand your own code later. I'm going to show the same calculation twice. The first version works but is unclear, but the second version works and explains itself. You can quickly see how this might get complicated. So set x is equal to 39.99. We can set this to 0.0625. Z is equal to x times y. And t is equal to x plus z. And now we can print, say we're interested in printing the variable t. We'll get around 42.49. But what does this mean? If you wrote this before and came back to it later, could you really remember what x, y, z, t means? Now, we could do the same thing, but with better variable names. Say we wanted to call this subtotal. Y is the tax rate. Now tax, total tax, is the subtotal times the tax rate. And the total is equal to subtotal plus the tax. And now we can print total. These lines make much more sense than these lines up here. If you come back later and need to modify the code, the second version tells you exactly what to change. But in the first version, we have no idea what's going on. This becomes more and more important as your programs get longer. Let's do some more practice. Say we wanted to have a city variable called Boston, temperature variable equal to 32.5 is raining is equal to false, favorite number is equal to 7, nickname, and we have no nickname. This makes a lot of sense. We'd want to represent Boston as a string, temperature as a float for maximum accuracy, is raining is either true or false, favorite number is 7, nickname, if you don't have a nickname, it should be none. We can run this. We've successfully set every single variable with the correct data type. If you can comfortably write a file like what I just did, you're building the right foundation. You know how to set a variable, you understand that values have types, and you can check what type something is when you're unsure. We're done with our coding portion for today. Like the Git workflow that we mentioned last time, we want to do something like git status, which will change what exactly happened from before. As a quick note, I moved hello.py into its own lesson here, so this is what that means. And we've created 2 new directories, lesson 1 and lesson 2. With everything in lesson 2. We'll do the git add command, git add period, we'll add everything that's changed. And then we'll commit that with a nice commit message. And we'll push that to the repository. There we go. That's it for this episode. If you're brand new, this is a bigger step than it sounds. This is the point where Python stops being random lines of code and starts becoming a tool that you can represent real information with. You now know how to create variables using assignment, and you know that a variable name is just a label that points to a value. You also know the core data types you're going to see constantly: int for whole numbers, float for decimals, string for text, booleans for true or false, and none for no value yet. The main Python idea behind all of this, Python is dynamically typed, so it infers the type automatically based on what you assign. The reason this matters is because everything we do here will depend on variables and data types. When we start writing conditional logic, the conditions will be based on booleans. When you start accepting input from users, the values will come as strings, and you'll need to recognize what type you have before you can use it the way you want. When we start writing loops, you'll be updating variables repeatedly as your program runs. When we start writing functions, you'll be passing variables in and getting new values out. This episode is basically the vocabulary you need before we can start writing programs that make decisions and respond to data. If you want to practice before moving on to the next video, here's what I do. Open a new practice file and add a few more variables that represent real things in your life, then print them and their types. Don't worry about doing anything advanced just yet. Just get comfortable with the idea that you can store information under a name and Python will track the type for you. Once that feels natural, you're ready to move on to the next episode. In the next episode, we'll be starting simple conditional logic. That's where we take variables and booleans and use them to make decisions, so your program can do different things depending on your data. Thanks for watching, and I'll see you guys in the next lecture.